So this one's titration. This one can get a little bit of funky. Hopefully we can do this really well. So what we're going to want to do is we need sodium hydroxide. We need some phenolphthalein indicator paper. Let me just show you what happens to pure sodium hydroxide on this little piece of paper. This is the phenolphthalein indicator paper. Let me just drop it maybe right here. I'm actually not going to do a full drop. I'm just going to touch it to there. There we go. Look at that pretty color paper right there. So that's what happens in the present to this paper in the presence of sodium hydroxide, which is a very nice base. And what we want is some vinegar. We got a big thing of vinegar here, and some distilled water. You will use this to calibrate your dropping bottles. So first thing I'm going to do is I'm going to close up the vinegar that I opened, and I have no idea why I did that. Oh, we also need the 24 well reactant plate, a graduated pipette. That would be pipette, graduated because it has little lines on it. A graduated cylinder, 10 milliliters right there. 2 beakers, small. A plastic toothpick and some white paper. I think the white paper is basically so that way you can kind of see your reaction. Let me angle this down a little bit. I apologize, my head's going to be cut off, but at least then you can kind of see the experiment a little bit better. All right, so we need to really do a good job at calibrating how much exactly one drop, how many milliliters is in one drop of these bottles. We're going to assume that all the bottles give the same volume of drop. And so what I'm going to do is I'm going to count how many drops it takes to get to exactly 1 milliliter. Let me just make sure it's nice and dry. 1 milliliter. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh shoot, was that 2 drops or 1 drop? Well, 18, 19, 20, 21. Okay. Also, be very careful. Hold the bottle straight up and down like this. Oh, I didn't want to get that in. I didn't get it in there, but hold the bottle straight up and down like this, and don't touch the tip of the bottle to the edge over here, because those won't be full drops. Now, what you're going to want to look for is this thing called the meniscus. What happens is this is so weird looking. Okay. What happens is the surface tension of the water and also the capillary action draws the water up on the edges. So you're going to see a bubble, or kind of the top of the water kind of curve down like this. When you look at the bottom of the curve, that's where you want it to match up to be at the 1 milliliter line. So the bottom of the curve is going to touch that. If it's so that the top is touching the 1 milliliter, that's not enough. And I put 21, and it looks to me like I am almost there. 22. All right. So I got 23. I don't know if that one's what you guys get, and hopefully maybe you'll get around something around 20, between 20 and 25. What you're going to want to do is do this again, just so that way you can really get a good idea of exactly how much water is in here. So I'm going to go from 1 milliliter in here to 2 milliliters, and I'm just going to drop it until I get, a good idea. So the way you find out how much water you have exactly, or how much one drop of this is, how many milliliters, is you just take 1 milliliter and you divide it by however many drops you put in. And so in this case, I would do 1 divided by 23. Whatever that number is, that's how many milliliters a drop of water is. You want to try to make sure that you're very, very precise with these things. All right. Now, what we're going to do is we are going to take vinegar. So I have my vinegar. I'm going to put it inside of a beaker. I'm just going to put a little bit of it. Okay, that's enough right there. And I'm going to take my graduated pipette. I'm going to suck up some of that. And then I'm going to make it so that way it goes right down to that 1 milliliter mark right there, that first mark. The stuff inside here is exactly 1 milliliter. I'm going to put it into a clean beaker. And then what I'm going to do is I'm going to put 9 milliliters of distilled water. So I'm going to dilute this thing by 1/10. Is that right? 1/10? Yeah. All right. So I'm diluting the concentration. So let me get 9 milliliters of water into here.
What are you doing?
Hi, Griffin. I'm recording a chemistry video.
What is this stuff?
This is a chemistry video.
What is it about?
It's about titration.
Science? What is that?
This is a graduated cylinder. Okay, there. A little bit more.
Who are you talking to?
I'm recording a video for my students. Okay, so.
Hello, students.
Okay, why don't you go downstairs and go watch the movie?
It's done.
Oh, we'll go play downstairs with the other kids. Okay, so I'm going to take this.
Can I help?
No.
What is it?
Okay.
Are you going to dip it in there?
Yep. So now I have my diluted vinegar solution.
What's a diluted?
A diluted, it means there's less of a concentration. So this was pure vinegar, and now I have diluted vinegar. All right. Now what I'm going to use is the graduated pipette to put 1 milliliter of solution into D1 through D2. So here's D, and I want to go D1 and D2. I want to put 1 milliliter of diluted solution into there. So here's my pipette. You know, I'm going to probably mix this up a little bit by just...
Mixing that with that's going to be a potion.
Okay, here. And then I'm going to put... Okay, there's 1 milliliter. I'm going to put it in D1.
This is what you're going to blow up.
And then here's another milliliter. Okay, wait, I didn't get it right. There we go, that's perfect. I'm going to put that in D2. All right. Now what I'm going to do is I'm going to tear...
What is that? Wait, no, what is that?
That's copper nitrate. We're not using that right now.
What is it for?
It's for the experiment. Give me a second. I'm going to put you outside and lock the door. Give me a second. Hold on. All right. Go downstairs and go have your mom brush your teeth.
Okay.
Hey.
Yeah.
Love you.
Love you.
Okay, go.
It's gonna blow up.
No, it's not going to blow up. Go. Close the door.
Okay.
Go downstairs. Close the door. All right. So I want to take 2 of these papers, and I'm going to rip off 5 millimeters. 5 millimeters is half a centimeter. Approximately. And I'm going to put it inside of this solution. So there and there. All right. I think I'm going to use this little plastic tube to kind of drop them in the middle over here. All right, we'll be good. Okay, so now what I want to do is I want to use this dropping bottle right here. And I've calculated exactly, each time I put a drop in there, I'm going to count how many drops I have in here. Each time I put a drop in here, I'm going to know exactly how many milliliters I'm dealing with. 1 second, I've got another kid trying to bug me. Hold on. I apologize. Okay, so I know exactly how many drops I need to put in order to, what's going to happen is turn this thing to this color pink that we have. Now, it's not going to be that bright or that powerful, but I'm going to slowly put these in. And I'm going to put it in the same exact fashion as I did the distilled water. I was practicing with the distilled water. So let's go. I'm going to count it. 1, 2. Oh, wait. All I did was I put in 2 drops, and I immediately saw a little bit of faint pink show up. Now, as the thing, it dropped straight onto the paper and it turned it pink, but it just kind of naturally went away. So what you want to do is, I'm going to put more of this inside, and what's going to happen is I'm going to stir it every so often until the pink color stays for more than 30 seconds. If you put too much, then and the pink color stays and it gets too dark, then you've messed it up and you're going to have to redo this experiment. So be careful, don't put too much. Less is always good. So I already put 2 drops in well D1, and I'm going to do a 3rd drop. Actually, that didn't change anything color. A 4th drop. A 5th drop. 6th drop. 7. Okay, I'm starting to slightly see some pink. Actually, I think that maybe that when I put the 2nd drop in and it turned pink is because I dropped it straight onto the paper. But let me see. I was at 7. This is 8, 9, 10, 11, 12. I'm starting to see a pink spot each time I put a drop in. 13, 14, 15, 16, 17. Okay. I see pink right now. And it didn't last for 30 seconds. But I feel like I'm getting close. So I'm just going to put a drop, steer, put a drop and steer. Okay. 1 drop. And steer. 1 drop and steer. And that's titration. That's what you're going to do. If your paper turns this color, you totally messed it up and did it wrong. Your paper should have a very, very faint pink to it. In fact, if you put it in and it turns pink and it holds that pink for 30 seconds on that paper, then it's good. If it goes away, it's still good. You can count that. As long as it's 30 seconds. Now, what you're going to do is you're going to repeat the same experiment with well D2. And you're going to do the same thing. And then we're going to average that. Just because we want to be as exactly precise as possible. We want to know exactly how many drops we put in. So I think over here I put 17 into well D1. And I can probably keep going. But I'm not going to finish the whole experiment because it's your experiment to do for yourself. And then you're going to find out exactly how many milliliters of sodium hydroxide you needed to put in there to turn that thing into to make that thing indicate into a purple solution, or the pink indication on that phenolphthalein paper. That's titration. It's a technique that can be really sensitive, so make sure that you practice a lot with this. Again, you can always just throw this down the drain, because this is just a little bit of sodium hydroxide with some vinegar to kind of balance it out. So you'll be pretty good there. Just make sure to use lots of water, clean up after yourself, and answer all the questions. There's a lot more questions on this lab than there are in other labs. And so there's a whole procedure that you're going to need to follow. But that was basically the basics, or the techniques you'll want to use in doing titrations.